Hello guys, welcome to the lecture on differential equations of higher order. In the previous lectures and all, we learned about how to solve homogeneous and non-homogeneous differential equations. So in the previous two lectures, we discussed about how to solve the non-homogeneous differential equations by using the particular integral concept. So already we learned about how to solve the functions of the form exponentials and also how to solve the functions of the polynomial equations. So in this lecture, I am going to discuss about the function of the form trigonometric functions. That is, if f of x is cos ax or sin ax means we will see how to solve that kind of differential equations. So here, the particular integral type 2, so the function will be of the sin ax and cos ax form. So if the function f of x is equal to sin ax or cos ax they have given means the formula will be like this. The particular integral is equal to sin ax or cos ax divided by f of d square. So here the d square will be taken for here we have to replace only d square terms, not d terms, not d cube terms and all. Only d square terms we supposed to replace here. So if d power 4 term is there means we have to expand like d square whole square and we can replace d square value there. If d cube is there means we can expand d cube as d square into d, we can replace the value of d square. But d term we can't replace. If the denominator contain d term means we have to convert the d terms in terms of d square and we have to solve the equation. So here, so the first step is we have to replace all the d square terms by minus a square. That is, this a is given by the coefficients of x in the trigonometric functions sin ax as well as cos ax. So we have to replace only d square terms by minus a square with the condition that f of minus a square should not be equal to 0. Suppose after replacing d square by minus a square, if I got denominator is equal to 0, what we should do? So same like the previous problem only, we have to differentiate the denominator with respect to d and multiply x for the numerator. Here we can see that I took example like only sin ax function. I replaced d square by minus a square, so immediately I got 0. So since I got 0 here, I multiplied x for the numerator and differentiated the denominator. Again I replaced d square terms by minus a square. So note that if d square terms are not there means we have to convert the d terms in terms of d square here. So same condition here again, f dash of minus a square should not be equal to 0. Again if it is comes 0 means follow the same procedure only, multiplying x for the numerator and differentiate the denominators. So now we will see a few examples related to the type 2. So the given equation is like this, d power 4 plus 4 into y is equal to sin 3x. So here the trigonometric function is there in the RHS. So we have to use for type 2 only. So first make the complementary function by making the auxiliary equation. So we know that the auxiliary equation is given by replacing d terms by m. So I got the equation like m square plus 4 is equal to 0. It implies m is equal to plus or minus 2i. So on simplifying m square plus 4 is equal to 0, we got the roots like m is equal to plus or minus 2i. This is a root clearly complex roots with the real part is equal to 0. And we know that the complex root is there means how to write the complementary function. The complementary function will be yc is equal to c1 cos 2x plus c2 sin 2x. So now we will see how to find yp. So yp is given by the given trigonometric function divided by operator equation. So in the problem the operator equation is d square plus 4. So the equation will be now sin 3x by d square plus 4. So now as we know that in the type 2 we have to replace all the d square terms by minus a square. So since here x coefficient is 3, so we have to replace all the d square terms by minus 3 square. So minus 3 square in the sense minus 3 into square, so it will become minus 9. So minus 9 plus 4 will become minus 5. I got the equation like sin 3x by minus 5. So note that here actually it is not minus a whole square, it is minus into a square. So it will become obviously negative. So the square is not applicable for the negative term here. So so I will get minus 5 only. So now combining both this yc and yp. So I'll get y is equal to yc plus yp. So the solution will be c1 cos 2x plus c2 sin 2x minus sin 3x by 5 is the solution for the given non-homogeneous differential equation of the type 2. Example number 2. The problem is d square plus 3d plus 2 into y is equal to cos 2x. So same thing here also, the function is having trigonometric function cos 2x. We have to use type 2 concept only. So first make the complementary function by making the auxiliary equation. So auxiliary equation is given by replacing d terms by m. So I got the auxiliary equation like m square plus 3m plus 2 is equal to 0. So here we have to observe that on multiplying we have to get 2, adding we have to get 3. So 2 into 1 I can take it. So I'll get m square plus 2m plus 1 plus 2 is equal to 0. On taking the common factors and all, I'll get the roots like m is equal to minus 1 minus 2. So here the roots are real and distinct. The complementary function will be yc is equal to c1 e power minus x plus c2 e power minus 2x. So now we will see how to find yp. So yp is equal to the function we have to take here cos 2x by the different operator equation, that is d square plus 3d plus 2. So as you know that only d square terms we have to replace here. I am going to replace d square by minus a square. So in this problem the x coefficient is 2. So we have to replace d square by minus into 2 square, that is minus 4. I will get cos 2x by minus 4 plus 3d I am keeping as it is. Since here only d square terms we are replacing, I am keeping the d terms as it is only plus 2. So now I'll get the equation like cos 2x by 3d minus 2. So here why I took multiplied with 3d plus 2 by 3d plus 2 means, so to convert this d as d square. So since here 3d minus 2 is there, if I multiply with 3d plus 2 for the denominator, it will become 3d square, 3d whole square minus 2 square I can write it according to the a square minus b square formula. So only I am multiplying and dividing with 3d plus 2 here, so to get of the form a square minus b square. So after multiplication I'll get the equation like 3d plus 2 into cos 2x divided by 9d square minus 4 square or minus 2 square according to the a square minus b square formula. So here on multiplying the equation, so I will get 3d into cos 2x plus 2 cos 2x divided by 9d square minus 4 I will get it. So and we can observe that d is nothing but d by dx actually. So d by dx of cos 2x will become, differentiating the cos 2x function, I will get minus 2 into sin 2x. Already 3 is there here. So I got the equation like 3 into minus 2 sin 2x plus 2 into cos 2x I am keeping as it is. According to the type 2 I am replacing d square by minus 2 square, that is minus 4. I got the denominator like 9 into minus 4 minus 4. So on simplifying this equation, we'll get the solution like minus 3 sin 2x plus cos 2x divided by minus 20. So I took 2 common factor. So the 40 gets cancelled here. So I got minus 20 in the denominator. So the yp will be minus 3 sin x by 20 minus 1 by 20 cos 2x. So next already we know that by combining the complementary function and particular integral, we can get the complete solution. So yc plus yp will get y is equal to c1 e power minus x plus c2 e power minus 2x plus 3 by 20 sin x minus 1 by 20 cos 2x is the given solution here for the given non-homogeneous differential equation of the type 2. So take few problems for assignment. The problem is y double dash minus 4y dash plus 13y is equal to cos x. And the one more problem is d square y by dx square plus 3 dy by dx plus 2y is equal to 4 cos square x. So on solving the problems, got any doubts means please give comment in the inbox so I can clarify the doubts here. Thank you.